Okay, so this is Math 146, Unit 6.3, Hyperbolas. This is the last of the three conic sections that we're going to talk about. Again, this is these cross sections are derived by slicing a cone with a plane in a specific manner. um, and this one, in general, will look something like this. It almost looks like a set of parabolas facing away from each other. They're technically not parabolas, but it kind of has that general look, or a hyperbola will look something like that. And some of the key components is that a hyperbola, very much like an ellipse, has multiple focus values or foci, and they will each be within the concavity of each one of the sides. So in other words, you could have a focus value right here, and then we would have one right here. It would be exactly equal distance from the vertex of each one of the different vertices of the hyperbola. So that would be a focus value, maybe focus 2, focus 1. That's horrible. Let's try and write that a little clearer. There we go. Excuse me. You're also going to have something that we didn't have with the other ones. You're going to have asymptotes. And basically, these asymptotes are going to look something like this. And that's kind of what the hyperbolas are going to ride along as they expand out further and further. And we'll get into how we find all of this stuff. It's a very, very similar equation to the ellipse. The major difference, pun intended, is that there is a subtraction in one of these. Let's talk about the actual definition of a hyperbola. Again, very, very similar to that of an ellipse. So if I were to take any point on the hyperbola, let's just take this point right here, and I were to measure the distance from one of the foci to that point, and then the distance to the other foci from that point, every single point that lies on the hyperbola is going to be the difference between the two, whereas the ellipse was adding them. This will be the difference between the two. So it's going to be the difference, and obviously it's the bigger one minus the smaller one, but every single point will have exactly the same difference between those two distances from the one foci to the point to the other foci to the point. So it is a difference there. Again, not something you have to know unless you're going to try and derive this formula, which again all stems from distance formulas. But basically, this is your formula. If we have a hyperbola, which hopefully you can see in this particular case only intersects the x-axis. There is no y-intercepts in this case. What we call the main axis is called the transverse axis. Transverse axis. That is the one that the vertices are going to lie on. And in this case, it's along the x-axis. So the equation would be x squared over a squared, the a still representing the location of the vertex, minus y squared over b squared, and that will equal 1. So as you can see, again, pun intended here, the difference between this one and the ellipse is that the ellipse would be adding those two things together. The hyperbola is subtracting them. And again, that comes from the fact that there's a difference between the two lengths. The nice thing is to find the foci, the equation is identical as long as I don't mess it up like I kept doing. Actually, I'm sorry, it's not identical. This is the one that I kept using for the ellipse and kept getting backwards. So for the ellipse, it would have been b squared equals a squared minus c squared. Well, it's exactly the opposite. This is the one I kept writing down. So it's b squared equals c squared minus a squared. And the reason that this one is nice, because literally if you were to add the a squared to both sides, that is the Pythagorean theorem. A squared plus b squared equals c squared. So this one's the nicer one in the fact that this literally comes straight from the Pythagorean theorem. A squared plus b squared equals c squared. We just use it to make it look similar by solving it for b squared. But it doesn't matter how you start it. You can find any of the missing pieces. And again, C is the location of your focus. All right. And the biggest difference is if your transverse axis happens to be the y-axis, so we'll sketch that. I'm not going to sketch the asymptotes with it, but basically it would look something like this, and then something like that. So now your transverse axis is on the y-axis. What changes in your equation is that now it's going to be a y squared over a squared. And again, the a part is going to be the location of your vertex, or your vertices, right there. That's your a value. Minus x squared over b squared equals 1. And in complete honesty, other than to sometimes to find the foci, the b isn't going to be as important. The b actually gives you a location and a way to find the asymptotes that we drew in blue. It helps to create this box, which will be a way to visually represent and figure out your asymptotes. I think it makes it easier for a lot of people to see. Okay, so those are your two basic formulas, and then again, these could be shifted. Right now, the center of these is both at the origin at 0, 0, and they could be shifted. Just remember that it's still going to basically be an x minus h and a y minus k that shifts them. We'll deal with that a little bit later on. Okay, so let's jump into an example or two here. And we are going to find the equation of the hyperbola centered at the origin. We are going to be told that one focus is at the point 3, 0, and we're going to be told one vertex is at the point -2, 0. And what we want to do is we want to write the equation and then sketch a graph. Okay, and we're going to sketch the graph in this case without worrying about the asymptotes. We'll get to that. So let's take the information that we have. So we know that the vertex gives us the a value. Extend the page there. There we go. So vertex is giving us the a value. So we know a is going to be 2. And we know that the focus gives us the c value, which is going to be 3. And because of the fact that these are both values in the x position, that means that the transverse axis or the main axis is going to be on the x-axis. Excuse me, that's where your hyperbola is going to intersect. It's going to intersect the x-axis. And I'll explain to you why it won't intersect the y-axis in this case. Okay, so let's take a look. We're going to need b, so we can find b. And again, you could start this one. It might be easier just to remember, okay, oops, this was being blue. This comes from the Pythagorean theorem. A squared plus b squared equals c squared. Well, we're solving for b, so we're going to subtract a squared. So let's put them in. B squared equals c squared, which is 9, minus a squared, which is 4. So b squared equals 5. Taking the square root, b will equal plus or minus square root of 5. Now we have enough to write our equation. So the equation should be, and remember, this is main axis, transverse axis, x-axis. So it should be x squared over a squared, which is 4, minus y squared over b squared, square root of 5 times square root of 5 is 5, equals 1. Okay, and that should be the general equation for that particular hyperbola. Now, what I want you to recognize here when we go to graph this, if all you were given was the equation, this would be a relatively easy graph to sketch because if you wanted to find the x-intercepts, you would let y equal 0. That would make the whole y squared over 5 go away, and all you would have left is x squared over 4 equals 1. Multiplying both sides by 4, x squared equals 4. X is going to be positive or negative 2. And that makes sense, given the information that we were given in the original part of the problem, because it told us that one of the vertices was at negative 2, 0. So we have enough now to at least do a basic sketch. Again, I'm not worried so much about the asymptotes just yet. And this technically goes on forever in both directions. Now, the question is, how do I know that I have this right? Well, there's no y-intercept, because if you think about it, if I plug in 0 for x, x squared over 4 is going to go away, and you're going to end up with this equation. To solve for y, you would have to multiply both sides by negative 5. And now what you have is you'd be taking the square root of a negative number, which would be an imaginary value. So it won't exist in the real numbers. So that's why there's no y-intercept, because it can't work out in the real number system. So that's how we know that we have this correct. All right, and we were given, let's see, what were we given? The foci would be at 3, 0, and then the other one would be at negative 3, 0. So if I wanted to sketch that, that would be one foci, that would be the other. And there we go. All right, so now let's say that we are given the actual equation to begin with, and let's see what we can figure out from that. So we're going to be given the equation x squared over 16 minus y squared over 4 equals 1. Again, there's no h or k, so we know it hasn't been shifted, so the center is going to be at the origin. The x is the first value, or the non-negative value, so you know that it's going to be transverse along the x-axis. All you have to do is take the square root of the denominator there under the x, and we're going to know what the vertices are. So you know that your vertices, just by looking at this, should be at positive or negative 4, 0. 1, 2, 3, 4, 1, 2, 3, 4. We'll go ahead and throw a point on each one of those vertices. You could pick other points if you wanted to try and figure, to make it a little bit better of a sketch, which would be great. Again, once we learn how to do the asymptotes, that'll really help as well. But we could just basically sketch this thing right from here. Let's go ahead and find the foci, though. I think that'll make it a little bit easier, because then you know at least how to surround that. And again, the foci are C. We know that this is going to come from a squared plus b squared equals c squared. May as well leave it in that form because of the fact that we need c anyway. So a squared is 16, b squared is 4. So you're going to get that 20 equals c squared, or c equals the plus or minus root 20. You could simplify that to plus or minus 2 root 5. And the square root of 20 is going to be someplace in between 4 and 5. So the foci are going to be, right in here, right in there, pretty close to the vertex. And then we're going to go ahead and just sketch what that would look like on both sides. Okay. So that's pretty good for that one. Let's take a look at one that's maybe not in standard form to start with, but we can get it there pretty easily. So we'll start off with the equation 4y squared minus x squared equals 4. And then we know it's not in its standard equation, this is not in standard form because the right side isn't 1. So we're going to divide everything by 4, which would then give me y squared minus x squared over 4 equals 1. And technically that y squared is over 1. That should help because you need to know that that's the a value. So we know that a is 1, or a squared is 1 also. We know that b is 2, because b squared is 4, and then we can find c. So a squared plus b squared equals c squared. So 5 equals c squared. C will equal plus or minus root 5. And when we put this into its correct form, we can see that the y was the leading term here, so the transverse axis will be along the y-axis. So this is going to be one that kind of opens up and down. And if we want to take a look at what that might look like, again, the main axis, the vertices are going to be at 1 and -1. So put a point there, put a point there. And then the square root of 5 is going to be something which is in between 2 and 3, slightly closer to 2. So your foci is going to be just a little bit outside of the 2's. And again, we can make a quick sketch. This time it's going to go up and down. And again, it should be symmetric. My sketches are not the best, but they are sketches. All right. So I think that's pretty good for that one. So let's go ahead and talk about this whole idea of the asymptotes now. And I'm actually going to use this particular problem to kind of help figure that out. This is where the b value actually comes into play, because what it's going to do is it's going to help us to create a box. So the b actually goes along the other axis. I can't remember what they call the other axis. I know the main one is the transverse axis. It'll probably come to me at some point what the actual other name of this one is, but I think it might be called the conjugate axis, minor axis, something like that. It might be, I think it's conjugate axis is what your book uses. In any case, we need both the a and the b value. So we have the a value because that's the vertex, that's the vertices. The b value is going to help in the fact that since b is 2, we're going to go out 2 units on the conjugate axis, and we're going to place our b values there. Now, these are not actual points on the graph, so I probably shouldn't have put little dots because it makes it look like they're points, but they're not. So now what that does, though, is it gives us a way to create a box. The box is going to go through the b values and the a values. So basically think of making a horizontal box or horizontal line through a on the top and the bottom, and then a vertical line through b, and it basically creates a nice little box. And the reason that that's important is because your asymptotes are going to go through the corners of the box. I'll try and put this in green here. So your asymptotes are going to go right through the corners of the box. Assuming I can sketch it, that's not bad, because it also should go through the center. And our center, again, is at the origin because it hasn't been shifted. Well, the general idea is, I mean, these are lines, right? These are linear, so you can figure out what the slope is, and since they both go through the origin, there's no y-intercept other than 0. So if you do a rise over run, you're going to go up, in this case, your a value, and then right your b value. So one of these is going to be the equation y equals, again, rise over run, up a over b times x. Y equals a over b times x. And then the nice thing is the other one is just going to be exactly the same, but with a negative slope. So that's going to be y equals the negative a over b times x. And what you might expect is if your transverse axis is different, then instead of a over b, it's going to be b over a. And you'll see that when you actually draw it. Now, I'm assuming everybody understands how to do rise over run to figure out the slope. And that's really how you write the equation. Some people just memorize whichever equation is. Oh, is it a over b or is it b over a? Depending on which way it is. You can memorize that if you choose to, but for me, it's just much easier to figure these things out by creating the box because I think it's a nice visual. All right, so let's actually go ahead and try one kind of from scratch, and we'll put everything into it on this one. So we're going to have the equation y squared over 4 minus x squared equals 1. So let's see. Y is going to be our transverse axis because it's in front, so we know this thing's going to open up and down. The a value is 2, so that's going to tell us the location of our vertices, positive and negative 2. The b value, again, that goes under the x part in this case, is 1, so that's going to tell me, in this case, that I'm going to have my box formed by those things right there. So I'm going to sketch the box. And I know my asymptotes are going to go through the corners and right through the origin. So I'm going to have an asymptote that does that. I'm going to have another asymptote that does that. And once again, the equations of the asymptotes are going to be y equals rise over run. It's going to be up 2 and right 1. So in this case, it's going to be y equals 2x. And then this one down here is the same thing, but negative slope. So it's y equals negative 2x. So there's your asymptotes. Now all we have to do is find the foci. So again, b is 1. So a squared plus b squared equals c squared. We kind of have a similar one here. 5 is c squared, so c is plus or minus root 5. And that's, again, going to be a little bit bigger than 2. So here's your foci. Now let's go ahead and sketch the actual curve. And it's going to go through the vertex, and it's going to ride right along these asymptotes. Like that. Through the vertex, ride the asymptotes. Something like that. Again, it's not supposed to cross through the asymptotes, just because my hands are not very steady when I'm sketching, but that's what it looks like. And we found a whole bunch of different things. Found the asymptotes, found the foci, found the vertices, pretty much everything we need to sketch. All right, I'm debating whether I want to do, let's just do one where no, I don't want to do that one. Let's do one where we've got everything shifted. And I think that'll be good enough. I think we can call it a day from there. Again, one of the things I want you to recognize, or hopefully are recognizing as we go through this, is what you're looking for in the equations. We're going to go back just to think about this for a second. Again, a parabola 2 units ago, one of the variables will be squared, the other one will be linear. Or the highest variable on one of the variables will be squared, the other one will only be linear. That's going to give you a parabola. In the ellipse, both variables are going to be squared, and they're all going to be added together. And then with a hyperbola, both variables are squared, but one of them is subtracted. So that's kind of what it is that you're looking for as far as how to determine which type of conic section we have. So now let's talk about one, again, where things have been shifted. So again, it's x minus h and y minus k, and that's going to help to give us our center. And then after that, everything else comes along with it. So we're going to combine a whole bunch of things all into this kind of last problem here. We are going to have negative x squared plus 4y squared minus 2x minus 16y plus 11 equals 0. So this should look familiar as far as you should recognize, wow, in this form, I'm going to have to complete the square. One of the other things you want to look for is the fact that the y squared coefficient is positive and the x squared coefficient is negative. And that's important because that kind of tells you the order we need to go in. So when I rearrange these, I'm going to put the y squared stuff first. I'm going to put all the y terms first. 4y squared minus 16y, leave a little bit of a space, minus x squared minus 2x, leave a little bit of a space, and I'm going to subtract the 11 to both sides so that I can get the constants to the right. All right, with the y squared, because I have a coefficient other than 1, I need to factor out that 4. So we're going to write that as 4 times y squared minus 4y, and once again, leave a space. And in the x one, I'm going to factor out the negative. So basically, it's a negative 1 out there. And then we'll have x squared plus 2x, leave a space. And now we got to figure out what it is that we're going to do to complete the square. So in the y part, we're going to divide the linear term, the negative 4y. We're going to divide that by 2, and we're going to get negative 2. Squaring that, it becomes plus 4. So I just added 4 inside that parentheses on the left side, but really technically I've added 16 because I have to multiply or distribute the 4 that I factored out back in. So I need to add 16 to the right. And in the second parentheses, taking the 2, dividing it by 2 is 1, squaring it is 1. But again, you have to distribute the coefficient in. So really, it's a minus 1 that I just actually put to the left. So I need to subtract 1 on the right-hand side. So let's go ahead and simplify everything now. So the first one is going to be 4 times, factoring that the y part should give us y minus 2 quantity squared, minus, don't really need the 1. You can write it if you want it. But that parentheses is going to become x plus 1 quantity squared. And on the right-hand side, we've got negative 11 plus 16, which is 5, minus 1 is 4. That works out very nicely. Because now to put this in standard form, we're going to divide both sides by 4, which will then give us y minus 2 squared, technically over 1, minus x plus 1 squared divided by 4 equals 1. And now this thing is in a standard form, which we can then use to find all the other pieces of information. So the first thing is our center is no longer at the origin. The center is HK, which in this case is going to be 2, negative 1. So let's go ahead and start by sketching that part. The center is now at 2, negative 1. So let me put a bunch of tick marks on here. I'm hoping 6 in each direction will be plenty. It should be. 1, 2, 3, 4, 5. I missed one. Okay, there we go. So at 2, negative 1 is our center. 2, negative 1 is the center. And that's where that little dot is right there. Okay, so now we need to go ahead and figure out the vertices. The transverse axis is going to be under the first term or the positive term, which in this case is 1. But remember what that does, that's your A value that tells you how far away from the center you are. So A is 1, which means I need to go 1 unit in each direction. And this is going to be up and down. This is going to be an opening up and down hyperbola because of the fact that the y is first. So if I move up 1 unit, there's a vertex. If I move down 1 unit, there's a vertex. So I can write the vertices. I'm going to actually write vertex because I'm going to write two of them. Should be at 2, 0 and 2, -2. Let's actually make that look like a -2. There we go. So there's my vertices. And boy, I hope that you guys have caught my mistake. Fortunately, I haven't gotten too far. I have been treating this like that first term was x and the second was y. I am completely backwards with my center. So let's change that, and I do apologize. Hopefully you haven't written all this in pen, but we can figure all this out. It should be at -1, 2, because the x value is the x plus 1 part. So let's erase this because that's obviously not correct. All right, so -1, 2. Again, we still is going to open up or down. That's now our center. Again, the fact that A is 1 hasn't changed. It means we need to move up and down 1 from the center. It does, however, mean that the vertices that I originally had written were completely off. So this one is going to be at the point -1, +1, and -1, +3. Yeah, that looks much, much better. Okay, we can draw the box because we have the b value. The b value is 2. Which means that we're going to move 2 units from the center, in this case in the x direction. So 1, 2, have a point there. 1, 2, we'll have a point out there. I don't need to write those points because that's really just used to create the box. So I will sketch the box. And then we can actually write the equations of the, or at least sketch the asymptotes. This one's not going to be quite as clear because it doesn't go through the origin, so you still have to be able to write a linear equation. So you have one asymptote doing that, and then the other asymptote doing that. I'm actually not going to take the time to write the equations of these asymptotes in this case, but you could write them because they're just linear. You just need 2 points in order to do it. And you could certainly use any one of the corners along with the center or whatever 2 points you wanted to figure that out. Okay, and then the other thing that we're going to need, since we have, let me go ahead and put those in blue actually. We have the vertices. We know we can actually sketch those. Oops. Sketch the actual curve. Got to ride along the asymptotes. Go through the vertices, something like that. The only other thing we would need to find would be the foci. Still the same equation, a squared plus b squared equals c squared. So 1 + 4 = c squared. Seems like we've seen this one a few times. C here is going to equal to plus or minus √5. And again, that's the distance that it's going to be away from the center. Is going to be √5. So just a little bit over 2 away from the center in both the positive and negative directions. So adding 2 spaces, 1, 2, just a little over that. There's 1 foci, and then 2 in the negative direction, 1, 2, so just a little bit below the x-axis would be your foci. All right, that is plenty enough. This was quite a long video, but the hyperbola is probably the most involved when it comes to that stuff. Okay, so there should be one major topic left, or one major unit left, chapter, however you want to say it. It's going to be Unit 7. We'll deal with sequences, geometric sequences in series, and this thing which is called the binomial theorem.